Oh, hello, everybody. I don't look great because I slept in my clothes and did chores, and I fixed the door, but then I realized the whole door knob thing is all messed up, so I'm waiting on a new one. And I finished the tile stuff. And then I was messing around with this microscope just to see if I could get the cameras to work, and now the lenses are acting really weird. So I'm just gonna have to return it and try everything. So now I'm going to share my screen, and today we are going to what we looked at a week ago. I have those genes. Let me just go to the I think it's in the Tableau. These ones right here. Leave. No, cancel. We'll just use this other tab. This one right here. And so I'm having a late afternoon Red Bull. All right, so last time what we did was we went through and found some relationships between the acute infectious mono and chronic active Epstein-Barr virus with these non-Epstein-Barr virus associated genes. So we went to MT1G and saw that, I'm going to select this, that there was a lot of upregulation of this gene in the acute infectious mono. And these are all fold change values. These are top genes here. We're selecting by the case study that we analyzed for top genes by fold change. And we found that in these non-Epstein-Barr virus associated pathologies like fibromyalgia, or specifically fibromyalgia, chronic fatigue syndrome, Lyme disease, uterine leiomyoma, and autism, we're seeing what, if any, relationship there is if this gene is even present. So it's not in the autism database, but there is a gene here in uterine leiomyoma that is inversely related to the acute infectious mono and the chronic active Epstein-Barr virus infection, which is also, they're very highly upregulated, almost twice as high in the mean values of the samples, as well as in fibromyalgia and chronic fatigue syndrome. Now, I'm not going to go over each one, but you'll see we're going to list these out. I didn't type this out at all, so I guess I could do that. So I'll go ahead and we'll do that. I'll just share this. Let's just go ahead and open up an RStudio document. Okay, yeah, we don't have to have any of this stuff open. Let's just go to the, and we'll just make a new folder. Mono EBV genes with non-EBV relationships. We'll just call it that. Okay. We're gonna open this. We're gonna set it as our working directory. And now we're gonna make a new file. And we're gonna call this gene relations between mono and EBV with non-EBV pathologies. Top gene comparisons. Okay. Now we'll go ahead and just erase this. I'm going to go ahead and right here, and then we're just going to make a bunch of chunks. We're not going to get in this right now because right now I'm going to go ahead and type all this in. Control C, copy, Control V, paste, 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 V, hold down the control, you do this. Who knows if we'll get this far? Maybe that's typically what happens. But for now, let me just type in what we went over last time. So we went over some Tableau genes in our top genes of non-EBV associated pathologies compared to top genes of many studies. We found the top genes by fold change values and tested for predictive accuracy to be better than 70% and some even 90% in classifying their respective class in that study. We now want to compare these genes that we viewed relationships of fold change from acute infectious mononucleosis, AIM, and chronic active Epstein virus, CAV. We compared about 15 genes that showed some positive and negative correlations. That is how big of a magnitude in the same or opposite direction the gene expression fold change of pathology compared to baseline pathology. Those genes and actually found. I'm just gonna list it out. Okay. And we're gonna save this. We're gonna save it as mono and genes compared to non-EBV. All right, let's just make a link right here. We'll go ahead and put this in brackets, and we'll go ahead and copy this one right here. Just the address, and paste it right there. Okay, great. Control C. And then, okay, so I'm gonna skip another line to this MT1G. And this one very upregulated, positive correlation with EIM as a fibromyalgia. And chronic fatigue. Slightly Lyme disease. We'll just call that LD. And the next one is here I am. One very related and LD. Slight and TFS and EBV. Okay, now the next one's TNFA. That's that 1P6 or TNFA 1P6. Oh, I think also it's on. I think it's on. 6. Oh, very down regulated. AIM. FM. LD. And user. Regulated. Easy. And slightly up. ANKRT 22. Very upregulated. And CAEBV. Uterine leiomyoma. Slightly up in AIM. Down regulated in CFS. LD. And lots of them. Bases also won't print it as a list. Very light up and CAEBV, CFS, and okay. Next one is HIS TH. Wait, TIH H3. Very up IM and no. Slight up and LB. Okay, OLR 1. Very down regulated and EIM and CAB and LD. 6 months. 6 months. The Lyme disease is 6 months. There's like 4 different classes, but I'll just put that. and very up regulated. And usually CFS. IRG1. Not in any sample. KIF11. Very up NAIM and EBV. Yeah. And fibromyalgia. Slight up in CFF. ILG. Very down in UNM and CABV and FM. Slight down in LD and slight up in CFF. ILIA. Very down in IM and CABV. Slight down in CFS and LD. DDL. Very up in AIM and up fibromyalgia. Slight up in myeloma and Lyme disease and chronic fatigue syndrome. Okay, FFAR2, almost done. Very down in AIM and CABV and LD and CFS, but very up in fibromyalgia and we already did this next one. I did it twice. I was getting tired though when I was doing this. Okay, so for that one, this one is up in AIM. Okay, all right, that's fine. And then GPR84, very down in AIM, slight down in CABV as chronic fatigue syndrome, slight up in myeloma. CCNA2, very up and fibromyalgia, slight up in LD and fatigue syndrome. Last one, CCL20, very down in AIM and CABV and Lyme disease, but very up in CFF. Okay, Control save. So now we want to make a table with these genes, but we're going to use all the databases the database that these aren't common. So we'll use the mono and active Epstein-Barr virus, but let's just compare it with what shows up the most. Let's use fibromyalgia. So let's just use all of them. Let's just see what it does. We're just using these genes, and then we're going to read in these data files. Okay. So let's go ahead and make a list. Let's make a list of it. Let's make a string vector of these genes to pull from these data sets. Okay. This will be the relation genes, and we're going to ASPM HISTI H3B OLR1 IRG1 KIF11 ILG ILIA UTL FIR2 GPR84 CCNA2 CCL20. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 12 genes. So we have 12 genes. 12 genes. See that? All right, let's read in some what do they call libraries? Are they libraries? Okay. Packages. Actually, just for now, we'll add in the random forest package when we need it later. Okay. So library are marked down. We'll go ahead and add it now. Random forest. It's getting hot in here. I'm gonna put this AC on. Oh. To where I keep these files, and we're just going to read them in. So we'll go ahead and get the. Oh, do we read in that vector string yet? Let's read that in to, and then. Okay. So I'll go over to those files. This what is this? The mono. Okay, so the Lyme disease, the chronic fatigue syndrome, fibromyalgia, the autism. Not really. We're not gonna do that. There, it was only like maybe one. I'm looking for the acute infectious mono and chronic active Epstein-Barr virus. I'm not really sure what I named it. Let's see. All samples, all cell changes. It should be in here. Definitely, we don't want that one, so it must be this one. Let me just make sure. Oh no, these ones. Not the data. I don't know why I didn't add it to this one. What's my sources? Making sure maybe I'm just overlooking it. So weird. I don't know why I didn't add it. What's the one? Okay. All pathologies. Okay. Where is it at? Mononucleosis. Oh. Dang it. Hold on. Okay, I didn't add it. Wait. What? Maybe this is the one. This might be it. All right, let's just open up our workbook to make sure that we have the right one. It will be this one. To make sure we got that right. So what did we name this one? Let's go to the data source. Here it is. It is this one. 32670 EBV. This one right here. Let's copy this. I'm not sure why it wasn't in. Where I put it in this one. No. Oh, I guess I did. I just didn't change the name of the folder. All right, that's fine. We're going to copy this one as a path. Go to R. And then we're just going to read in this file. Okay. monoEBV. Control V. Alright. For this one, we'll go include equals false. We'll copy it. Eval equals false. Path to this one equals false. And eval equals true. And then we'll say, okay. Actually, this will be the path mono. And then we're going to call this monoEBV read.csv. This file. We're going to cut this out. And put some quotation. Right, and for this one, we're going to put warning equals false. And we're going to set the character to path mono. So we'll run this. Oh, yeah. Forward slashes. And we'll go to this microscope, put in selection. We'll put backslash in that one, replace with forward slash. Okay. Now we can use it. Cool. We don't run this one. And then we'll run that. Alright, so that one is page nonEBV, but only the first 10 rows. And this one is nice. Alright, so great. Now we'll go ahead and save that. Might as well keep that one open. Now to go ahead and make another path. Let's just go ahead and copy. We'll just keep doing it for each one. Okay, so let's read in. Let's make a note. The monoEBV data set first. Now let's make the fibromyalgia, then the other data. So that's out of non-EBV, all of these. Chronic fatigue syndrome and Lyme disease and uterine myoma. Okay, let's go to our fibromyalgia one now. Let's copy this as a path. And let's put in selection and then replace the backward slashes. going to be include equals false. This one's going to be eval equals false. We're going to just copy this and then put path to. Okay, and we need to cut this out. And now we'll call this FM. And we'll put, let's set the working directory. Set working directory to the path FM. FM, we're gonna read.csv, control V paste. We're gonna put warning equals false. Okay, so now we'll run this one. Okay, and this one has 20,142 by 17. Table, first 10 rows. We'll just run this line. Okay, great. Okay. Save it. And now we're going to go to the chronic fatigue syndrome. Then the line. Let's go ahead and put include false, val equals false, and then warning false. Set working directory. This one will be CFS. Read.csv. Okay. Okay. Path to CFS. So then it'll be CFS. Alright. So right here, let's go to the chronic fatigue syndrome data set. Copy it as a path. Back to R, control V paste. Let's go ahead and switch that out, select there. Okay. Let's cut this. Name, oh, we don't need that right now. One. Paste. Alright, we'll run this line. Now we'll skip that other line and run this chunk. Oh, oops. That's CFS. Okay. Alright, and this one, 39, 37, 8, 174, very huge data set. First 10 rows. Yeah, there's like 75 and 90, so it's gonna be okay. So include equals false. These chunks eval equals false. This other one is going to be warning equals false. And then set working directory path LD. I'll just put line. Okay. So path 1, and then path 1, path 2, and 1. Let's go get this path to the Lyme disease data set. All right. Wow. Okay. Which one was the last one? Okay, so we're gonna have to go to Tableau, and then we'll just look and see. We use the median 99 bars one. Okay. Median, this one. Lyme disease. Let's make sure it's the right name. Means added. Oh, we have multiple Lyme diseases here. So it's most likely the last one. Normalized FCs means added. Lyme disease, normalized FC added. This one. Absolutely. Oh, okay, this was it. Yeah, that's right. We went through some stuff with this one. Okay, we're gonna copy it as a path. We're gonna go here and Control V paste. Let's go ahead and select all of this and replace with the forward slash. Good. Now we can cut this and here. We'll run this chunk and we'll run this chunk. And this one has 19,506 by 95 variables. Page, table, line, rows. Okay, great. One more, the fiber, uterine leiomyoma. Now, the leiomyoma. Okay, set our chunks to be include equals false for that path with personal folder markers. Next one, eval equals false. And then this last one, warning equals false. Okay, and it's going to be path UL. And then the next one, also path UL, path 2. And this one, set working directory, path UL. UL, read.csv, quotation marks. Let's go in and put the page table. First 10 rows. Okay, let's go get the path to the uterine leiomyoma data set. That one is. Let's see. This one, uterine fibroid. Pretty sure it's this one, but let's just make sure. UL all FC 66735 not filtered. It's actually the other one. It's not showing me all of the files here. Okay, so it's this one. Let's copy that as a path. Go to R, Control V paste. Let's go ahead and switch those backward slashes for forward slashes. And now let's cut out the name of the data. Paste it here and here. Let's run this first chunk. Skip the next one and run the other one. Okay, and this one has 58, 35, 36. Okay, let's save that. We can close out the Microscape search box. And now we have 1, 2, 3, 4, 5. Now we have 5 data sets to call genes from our relational genes string. Genes. Okay. All right. Let's go ahead and just take the string. We're just going to take the genes from each one of these by gene name. And then, ooh, wow, okay. And then all these samples, there's 174 in this one because it's got the most samples. The case and control here will be the healthy, and then the case will be the chronic fatigue syndrome. We're going to have to group that and make those samples. Okay. So we can actually just all right. Let's get the let's get the column names of the mono EBV, because these are the top genes we're comparing. And all right. All right. So we don't care about the fold change, or we don't want to use the means or the fold change values for this. We just want the actual samples and then the gene. So we're going to go ahead and we only want the actual samples and the gene ID. The gene name for all of these data sets. So we will omit the mean and FCs from each data set, as well as the ensemble ID and other features if present. And non-mono EBV. And then we'll just put the strict. We'll just put strict. Oh, we know. So it's gonna be mono EBV, but it's only gonna be all the rows for now. Or actually, We might as well just put it right here. Which mono-EBV by gene percent in percentational genes and only 2 through 19 and a gene name. Page table mono-EBV strict. All right, cool. So there's only 9 genes in this one. All right. And then we have our breakdown of the healthy and the chronic parvovirus and the acute infectious mono. So we're going to go ahead and make a class string for the mono. Okay. Let's just go down here and put column names of mono EBV strict. Okay. So we have class mono. This is going to be added matrix once we make it to that data set. Okay, and we'll be, I believe, row binding once it there. Yeah, row binding. And as long as the genes are in order, some will be excluded. All right, and class mono. Okay, so EIM group names mono EBV strict EBV group. Let's call it CAEBV group. Column names mono EBV strict. Oh yeah, but it's gonna be AIM, and this one's gonna be the ABV. All right, and then healthy. Class mono. All right, class mono. Are these in order? No, they're not in order. There is one. These two are switched. Oh, and then also these ones at the end. We're gonna keep it like that, but we'll go ahead and all right. If we do that, we'll have to reorganize the columns as well. So Let's keep them out. And see. Alright. We're gonna have to organize the data set also to be that way. And we'll just call it monoEBV. Organized. Okay, so it's going to be mono EBV strict, but we're going to reorganize the columns of healthy. And all right, let's just run this. Let's see the column names. EBV organized. And they're in order now. And then the class mono. Oh, okay. Class mono is going to. Okay. Here we go. Mono AIM. AIM. Oh, class mono AIM. Class healthy. Healthy. All right, let's do it again. All right. So this one will be removed. We're just using it. Oh, well, actually, we will go ahead and just use the, we'll remove the mono EBV organized. We don't need that anymore. And we'll delete this. And we're gonna go strict. Okay, and then let's compare the two. And 3, and then I see here, 4 CVs, and then all the healthy, and then 2 AMs. Okay, good. So those match. Those match without arranging order of the samples. Okay. Okay. Let's now get the fibromyalgia data set samples. Let's look at the. Okay, yeah. So we'll call this FM straight. And then we'll go to EBV. And wait, no, not that. Okay, FM. And then let's get the column names. Let's go ahead and look at that first. Let's just run that line. We'll cut that. Paste it there. All right. Gene name. Yeah, the gene name. We want the samples, but not the means. So we also want only the genes. Which FM by gene name percent in percent relational genes, and then the rows 2 through 14. Page table FM strips. Oh, there's only 4 genes in this fibromyalgia one in our relational genes. All right. And we'll just look at the samples. Okay. Column names. FM strips. And let's make a class feature. We'll call it class, but then healthy. FM, I'll call it healthy FM. Rep healthy. Column name FM strict. And then rep column name FM. And then class. Wow. Hold on. I was thinking if we're gonna have an error here because we had that extra class right there. Add another one. So weird, right? That's an odd one. I'm not sure what happened, but we went ahead and decided how many to make. I only added this one. I still added that is weird. Class mono. Oh, okay. Class mono. Okay. Let's remove this. Let's see. And then I'm going to remove class. Okay, so you have to set it. Alright. You have to initialize it. Alright. Okay, and then for this one, let's class FM class. Let's look at the class FM. Oh, right. Healthy. Healthy. Class fibromyalgia. These are the indices. Fibromyalgia. And then class FM. Fibromyalgia. There it is. And the first 1, 2, 3, 4, 5 healthy. Okay. Huh. E and then FM. Okay, the healthy share. Healthy. Okay. Now let's erase. Remove. Plus mono. Plus FM. Now everything below. We should actually make the class say Gene. We'll default it to Gene. And let's erase it again. Oh yeah, because we ran everything. Okay. Remove class mono, class FM. Okay, and then we're gonna rerun it again. Run all chunks below. Gene, and our class for mono is Gene. Now we can distinguish where our healthy samples came from, which data set. When we put these together, okay. We have the gene there. All Right. And they're all. Okay, yeah. So 5 healthy samples and then the 7 fibromyalgia. Right there. Okay. Alright, now we're gonna do the same exact thing to 3 more data sets. That one being okay, see, how about the Lyme disease one? Now it's getting cold. Let's just do this chronic fatigue syndrome one. So let's go ahead and get chronic fatigue syndrome data in same format. Okay, so we only want the gene name and the actual samples. CFS strict. CFS which CFS by gene name percent in percent relational genes and a vector that goes up to 171 from 4. So it's 2 and then 4 to 171. Column names CFF shorts. Okay. And let's make this class here. Class EFS gene and then CFS. Let's just put CFS little is going to be grep case CFS strict column names. And then healthy grep control column names CFS C's assigned CFS chronic fatigue syndrome. Class CFS by healthy CFS. Assign healthy CFS. Okay. Second one's healthy CFS. Let's look at the healthy is the CFS. Well, let's just pick a number 133 CFS. 133. That's because it says case. Mom's on 81 healthy. 81 healthy. Well, safe to say those are in alignment. And the first one's Gene. Okay. Now, let's do the same process to the UL data set. Then we'll do the Lyme disease. Okay. Column names UL. Okay. So we'll have to give a sample. I already did this into white myomicrofibroma or a uterine myo is not. Okay, so for this one, we're gonna have the same thing with the Lyme disease because there's like 4 different classes. All right, and let's see, when we took the full change, it was from all of them, from all, meaning both sets of, so we do only want the samples, so nothing with the mean. And the means start right here. There should only be 12 samples, I believe. Yeah, because we're 16. Wait, let's see. There's 3 black, 3 white for each of the normal, which is in, or the uterine fibroid, or the uterine fibroid next tissue next to it, which isn't part of the fibroid but is at risk of it. Okay, so our samples are from 22. So it's going to be from 4 to 22. Yeah, 6, 9, 12, 15, 18 samples. Okay. So we're going to be UL strict. It's going to be UL. Which UL by gene symbol, %N, relational genes. And then it's going to be the second one, and then 4 through 22 for just the samples. Wait, 21. Okay. Column names UL strict. Okay, just note that in this study, the MyF is at risk tissue next to the fibroid N is normal myometria tissue from somebody completely different, and the UF is the uterine fibroid. Okay, so we're gonna make a class of UL, assign it gene, and then we're gonna get the healthy UL will be grip myo N, and it's going to be from column names UL strict. And in the UL strict, there are 8 observations from the 12 genes. Same as chronic fatigue syndrome, there's only 8 there. All right. Column names UL strict. Okay, and then the UL will be grip UF column names UL strict, and then UL risk grip my OF column names UL strict. Class UL, the indices of healthy UL, healthy uterus, my class UL indices, uterine leiomyoma, class UL risk indices, UL risk. See, I'm wondering if we should even. Okay, so UL, I'm just gonna put risk. UL, and it's class UL. Okay. Class UL, let's look at it. All right, they're in order. So it's UL risk, healthy, and then just like it is here. So this is the risk, the healthy, and then the thyroid. Okay. Now for the Lyme disease one. And then we'll compare the genes by which 2 sets of data have the most in that. I should all have a sample in each category, but I guess I'll just, when that time comes, I'll just put healthy. So we'll add it all together, we'll grep anything that has healthy in it, and we'll just assign it healthy. So we will have 2. No. For the Lyme disease. Be arranged. Okay. Column names Lyme. Okay. We have healthy acute and 6. So we'll put healthy. And then Lyme disease. All right, but we need to also just get the data that is. So it's pretty much columns 1 through 87, only the samples. Okay, Lyme strips. Which Lyme by gene, %N, relational genes, and columns 1 through 87. Column names, Lyme strips. Okay. I'll just make a note of how many genes are in each 8 genes of the 12. And then the other one. The CFS has 8 genes of the 12 relational genes. And has 4 of the 12 genes. And then the mono has 9 of the 12 relational genes. Okay, Control S save. Let's go back to this Lyme disease one. All right, and we're going to make that class feature for it. All right. Lyme, class for Lyme. Assign it gene. And then for healthy Lyme, we're going to grab, what do they call it? Healthy. Just make sure if it's a lowercase or uppercase. Lyme strict. And then the next one will be acute. Acute. Make sure it's all cute one. And then just put these two together. I'll just put it all lowercase Lyme. Okay, Lyme group 1. Column names 1, 6 month. Lyme strict. Now let's assign these indices. They're named by class. Class Lyme. And then the indices healthy Lyme. Let's assign it healthy Lyme. Healthy before Lyme disease. Okay. Acute Lyme disease. Acute Lyme disease. 1 month. Class Lyme indices. Lyme disease 6 months. Okay, and then let's look at the class Lyme. And we'll compare it. Is 87 6 months and is 78. 78 and 87. 78 is 6 months. And 0. Does antibodies 1 month start at 51? Let's go down. 51, yes it does. And then does acute start at 23? Yes, it does. Okay, and the rest are healthy before it. And then the gene. All right, great. Okay, so we got data in order. Now we're going to look at which genes are in common. Let's get the ones that we're working with. So we have 5 data sets. Okay. Well, let's just look at them. Okay. CFS strict by right. F9 strict by G. Alright. All one. We can make the data so that Lyme strict gene. To affects all the genes are in fibromyalgia. Let's see if they're all in mono EBV strict gene. Yeah, they are right there. And then the other one is UL strict, right? Okay. Those 4 are in there too, so looks like before, genes are limited in the user predicting class of symbol. All right. So we could just do that. Okay. So genes for strict by genes alone. All right. So now we're gonna go ahead and CFS4 else strict, which is strict by genome and genes 4 samples. Mono 4 strict, which nonEBV strict by gene and genes 4. And then line 4 one strict, which one strict by gene percent and percent genes 4. And then we're going to go ahead and the next one will be these mono chronic fatigue fusion fibroid. So Lyme disease, fusion fibroid, chronic fatigue. Oh, fibromyalgia 4. Oh, wait a second. UL strict? Oh, no. Oh, okay. Actually, it's FM strict, because those are the FM strict has the FM strict. And then the UL for what? What is it talking about? 0. FM strict by, it might not be the same name. Gene name. Okay, that's better. UL 4 is strict, which UL strict by genes symbol percent genes 4. All right. Using All right. So now let's look at what. Let's say this. Okay. So we're gonna make a matrix of each of these, and then we're gonna add the class feature to it individually. Right. Our matrix for each of these and add each class feature we just made. All right. See. Dot frame for transpose CFS4. Let's run that. All right. And we'll go ahead and let's not. Okay. We're just gonna add in how long is it? 4. Okay, so 169, so 2 to 169. 2 to 169. Let's see what. Column names. Right. ACFS4 by team name. All right, good. And then let's go ahead and add in the class feature, but only the second through the end of it. CFS4 T by class will be class CFS, but only to length of class CFS. No, that's all right. Healthy. Okay. Case is correct. Oh, good. You can just compare it across the row name. Okay. Class. Then we're going to do a row bind with all of these. Okay. Okay, so we have the CFS one. it's going to be different for each one. So let's just and now sure, because we used this one, so M for trans will be data frame transpose FM strict, but it will be 2 through 13. Column names FM 4 transposed will be FM 4, wait, FM strict on Gnu case underscore between. Oh, they have the same name. And FM4 class will be class FM length of class FM. Page table FM4G. Okay. So these are not going to be able to row bind if they're not in. We'll have to make this the correct order. So, all right, we'll go ahead and just, it's only 5 data. We'll just do that now so that it's, okay. DTL, so it'll be we'll make it for CFST. Or we might as well just make it in order. See, let's go ahead and do that. Okay, CFS4, FS4, transpose. The rows will be all the same, but we're going to reorder this in order. So it'll be 3 for CC, NA2, 1 for GTL, 4 for FFAR2, and then 2 for KIF11. And then the class will be 1, 2, 3, 5. Column names CFS4, T2. Okay. They're in order. Good. Let's go ahead and do that to this one as well. Fn for T2, Fn for T, all the rows, and then it'll be the fourth one, the third one, the first one, the second one, and then the fifth one. Column names Fn for T2. Okay. T2. Okay, cool. Now for the Lyme disease one. Let's do the matrix. We just made the CFF times the G column. Okay. So this one will be Lyme 4 transposed Lyme 4 2 through 87. Lyme 4 transposed Lyme 4 by, what's the gene name? Gene with capital G. And then Lyme 4 transposed by class Lyme, class Lyme 2 through length of class Lyme. And then page table Lyme 4 transpose 1 through 10. Okay. Let's go ahead and rearrange. Lyme 4 T2, Lyme 4 T. All the rows, but we're not. T3, 4, 2, 1, and 5. Column names Lyme 4 T2. Okay. Okay, cool. Next will be the UL matrix. Here, UL for UL 2 through 19. UL 4 for gene symbol, capital space symbol, and then UL 4 transposed by class of UL, class UL 2 through length of class UL. Page table UL 4 transposed first 10. Okay. Now we will alphabetize. Alright, UT2, UL4. T, all those alphabetized. So it's 1, 4, 3, 5. Column names, UL4, T2. Good. Now let's do this to the mono. And we'll be done with that, and we can combine it and then run a machine learning program on it to classify and see how. The last matrix of the mono and B. Okay, so mono 4, mono 4, mono 4 times 4 by chain all lowercase. Mono 4 by class mono class mono. It's 18, 2 through 18 actually, right here, and then mono 4. Okay, and let's go ahead and let's arrange this in order. All right, mono 4 T2, mono 4 T, mono, it's gonna be 2, 3, 4, 1, 5. Column names, mono 4 T2. Okay. Now let's see if it'll let us just R-bind all of these. Okay. Let's save it. Okay. Let's row-bind these samples together. Same IDs by gene and class. Let's just copy that. All right. We're going to. Okay. Okay. Matrix 5 sets. Okay. R bind. Okay. Mono 4 T2. FM 4 T2. CFS 4 T2. UF4. Is that right? UL 4 T2 and line 4 T2. 1, 2, 3, 4, 5. Paste table 1 through 10 and 50, 75, 100, 125. Okay, let's see if it works. All right, awesome. Okay. All right. So let's just look at that matrix 5 cell. So let's go ahead now and out. So matrix 5 sets. Right. CSV matrix 5 sets. Matrix CSV row dot names equal false, and then we're gonna put eval equals false, so we only run it once, and if there's an error and it does something else later, it doesn't overwrite it. Good. Now let's replace the healthy examples to only have one example name healthy. Let's look at that table, matrix 5 sets by class. We can see how many examples we have. So we have a healthy. Okay. 1, 2, 3, 4, 5 healthy, because there's 5 sets and they all have healthy samples. And then maybe we should just put Lyme disease. And then anything with uterine leiomyoma, we should just put uterine leiomyoma tissue. Okay. Okay. So let's do that. Healthy 5, grep, healthy, matrix. Yeah. Class healthy 5. I'll sign it healthy. Now table matrix 5 sets by class. So there's less of those. That's great. And now Lyme disease. All right, let's go ahead and wonder, should we write this one too? Yes. Let's put eval equals false. Right, does matrix 5 sets. Sets healthy 5 replace merged healthy into healthy 5 into 1 healthy .csv row dot names equal false. And then let's go ahead and we'll just leave this how it is. And then let's go ahead and do some random sampling. Set.seed 1, 2, 5. So it regenerates the same results each time you run it. It's a random sampler. In train, we have 301 right here. 301 samples. These are our samples on the rows. The genes are our features we're predicting on the class. Okay. In train sample. 1, 2, 3, 1.8 times 301. Train is going to be matrix 5 sets in train. Testing will be matrix 5 sets negative in train. Table training by class. Okay. Now let's see how many samples are in the testing set. One, two, three, four, 5, 7 classes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes in the set. Oh. Okay. Let's go ahead and make a random forest. Training 1 through 4. Training by class and try equal 3. Let's just do that. Entries equal 5,000. Confusion equal. And by confusion. Random 4. 1 through 4. Oh, I forgot to make it a factor. Okay, so we have to make the class feature. Matrix 5 sets by class else dot factor matrix 5 sets by class. So all of the mono ones were correctly predicted. 60% of the Epstein-Barr virus active were predicted correctly. 51% chronic fatigue syndrome. 33% of the fibromyalgia. 43% of the healthy. 50% of 1 month Lyme disease. None of the 6 months Lyme disease. 43% of the acute Lyme disease. none of the uterine fibroids, at-risk tissue, were predicted correctly, and uterine leiomyoma only 20%. Now let's look at where be. So the surrounding tissue are predicted to be a fibroid for the fibroid at-risk tissue. And one was predicted to be chronic fatigue syndrome. And then 3 were predicted to be healthy, which makes sense because it wasn't technically uncontrolled cell growth in a fibroid. It was a tissue surrounding it. Now, chronic fatigue syndrome, 35 of those were predicted correctly, 34 were predicted healthy. None predicted as Lyme disease, so there's no connection there. None there. None with uterine leiomyoma. So there is only healthy or chronic fatigue syndrome for that one. Wasn't predicted as mono or Epstein-Barr virus. So we can see from this, there's like 0 possibility that it's related to mono, Epstein-Barr virus, or Lyme disease. Because look at these ones too. 0 predicted for that. 0. And not for uterine fibroid. So chronic fatigue syndrome is definitely a neuroplastic syndrome. Very healthy otherwise, but they're just so tired. And then we have some healthy samples were predicted as chronic fatigue syndrome. 39 of the healthy were predicted healthy. 1 was predicted fibromyalgia. 9 were predicted as 1 month of Lyme disease. 3 as 6 months of Lyme disease. 5 as acute Lyme disease. 1 as uterine fibroid tissue at risk, and 2 as uterine fibroids. Well, that's interesting. Let's see if it will predict any better. Let's see if it will predict any better. 100% accuracy on the acute infectious mono in training and chronic fatigue syndrome has 0% of being related to mono or EBV or Lyme disease or UL because it was only incorrectly classified as healthy when it was CFS. Okay, other interesting insights from the model. Okay, prediction 1, predict RF1 test on testing set. Results 1, data.frame predicted equals prediction 1, actual equals testing by class. It predicted it. Oh, look at that. The first 3 are correct. And it tells you the row name to healthy. Healthy. Okay. Healthy. had healthy and chronic fatigue syndrome. Couldn't really tell the difference. And that was the data set that had the most samples. So it does play a role in the random sampling. There is a way to balance it too, but I already forgot. I looked that up before. Well, uterine leoma at-risk tissue is predicted as uterine leoma. Well, uterine leoma was predicted as at-risk uterine leoma. Healthy was predicted as 6 months Lyme disease or acute Lyme disease. Lyme disease. Okay, well, acute was predicted acute. That's good. When it gets to the Lyme disease, acute. Many were acute, but some were predicted healthy. One was predicted chronic or 1 month of Lyme disease. Lyme disease. It's either Lyme disease or healthy for the Lyme disease. It was Lyme disease. All right. Interesting results. Actual samples. See. Timeline of exposure to it. Yeah. All right, cool. So that's it for today. We can keep on doing this with the GIT and lymphoma. Epstein-Barr virus associated pathologies as well. But we need more time. Let's go ahead and knit this. Oh, you can look through each study at my RPubs site for these data sets. I can't upload each and every one of them because I think that some of them. Okay, well, let's try. Oh, let's do this at the beginning. Let's do the beginning of this one. Okay. What's the other one? Okay. Let's see if I can find it on my Google. That's the one, right? Copy link. Paste it here. Save. Then I'll go back. And then let's go to the I think it's this one. No. It's not. It's, I think this one's it. Cause I named them something different though. Hold on. Is the date the same? Fibromyalgia. This one might be it for fibromyalgia. And then I think this one is it. For Epstein Barr. Let's get the chronic fatigue syndrome. Is it maybe that one? Hold on, let me see. No, it's UL 58735. But sometimes I name something else. Uterine fibroids. It's not that one. Oh no, because that's the pathologies with the fibromyalgia added. Not that one. Let's see what the date is. March. Right, March. Here we go. Did we use the NAND? I think we did. Yeah, it is that one. Okay. Control S, save. All right, perfect. Let's to run these chunks of code in down for the top. Okay, cool. Thanks so much. All right, let's go ahead and knit it. All right, great. So I'm gonna publish this, and I'll just put the link on this YouTube. From dashboard. nonEBV. And the dashboard genes of the word genes and autistic syndrome, Lyme disease, and Elma, as well as be active. Found some interesting. Let's show. Four. I'll just put one. Well, I know what those are. Okay. Now I'm gonna put this in the link. Awesome. Cool. So we'll have more stuff to do when we get to those comparisons. We can do an infinite number of comparisons, though. This was a really cool way to see if there's some kind of connection between these non-Epstein-Barr virus related or idiopathic pathologies with any other pathology. Okay, cool. So yeah, you can look at that and have fun. You can get this document, look at the links above in the document, make sure everything looks okay. We didn't get it listed out. Here's the Tableau link to that data, as well as the data sets that we use that will be named differently. Okay. Awesome. That's awesome. Well, thanks so much. It was great chatting with you guys again. Have a great night. Until next time.